Hello students, welcome to Saurav Sir's classes. Today we are going to solve DSE 2015 question paper, that is exam held as entrance exam for MA Economics. So in our last videos we have solved questions up till 8. So now we are going to start with question number 9. So question 9 says the vectors v0, v1 up till vn in Rm are said to be affinely independent if with scalars c0, c1 up till cn we have the condition here, that is summation over I equal to 0 till n, and the product of the scalar multiplied with the vector is equal to 0, as well as summation of ci from where I is equal to from 0 to n equal to 0 implies that ci is equal to 0 for I equal to 0 till n. So here we have the condition for these vectors to be affinely independent. So for such an affinely independent set of vectors, which of the following is an implication? So here we have three options, that is three statements, and we need to find which of these three are true, and accordingly we will mark our answer. So as you can see here, we have a finely independent set of vectors. So we know a basic rule that always linear independence implies towards the affinely independence. But is this reverse possible? Answer to this question is no. Reverse is not possible. Only linear independence can imply towards affinely independence, but the reverse, that is the vice versa, is not possible. Affinely independence does not imply that the vectors are linear independent. Hence you can see here we have been said that from v0 till vn are said to be affinely independent, and the first statement says v0 till vn are linearly independent. So this statement cannot be said because the reverse is not allowed here. So our first statement is a false statement. So with the help of this data we can check our options here. In options A and B, both options say that 1 and 2 are true and 1 and 3 are true. So both the options include 1, which is a false statement. Hence our answer cannot be option A, and neither it can't be option B. So we are left with two options, that is option number C and option number D. So seeing these options, you can see that in option C we have only 2 is true, and in option D we have only 2 and 3 are true. So if our answer is between these two, we know that our statement 2 will be true because both the statements say that 2 is true. Hence we need not check our statement 2 because our options directly say that our statement number 2 is true. So all we need to find is the condition for the statement 3, that is n is less than equal to m, and our answer can be found simultaneously. So let us assume a different vectors here. So let us assume three vectors from R2. So let us assume three vectors from R2. These can be, let the first one be u0, which can be written as e1. Second can be u1, which is written as 2e1, and third can be written as u2, which can also be written in the equation as e1 plus e2. So here we have assumed three vectors from R2. So seeing these vectors, we can say that these vectors are affinely independent. These vectors are affinely independent. But as I said here, affinely independent does not imply linear independence, and you can see here that these are not linearly independent. If we have a set of vectors who are linearly independent, we can directly say that those are affinely independent. But if we have a set of vectors those are affinely independent, we need to check whether they are linearly independent or not. But by this equation, by these equations, these vectors, we can directly say that these are not linearly independent vectors. So from this we can state our n will equal to be m. So from this we can have, that is m is equal to n, and as you can see here our m is the total space we have taken here, our M is in the question, you can see here we have Rm, so M is the total space, N is the only number of i's. Here we have number of I in which we can put this summation, so N is always less than M. Here we will have N is less than M. That is the only condition. N cannot be greater than M because N is a part of M. Here we have chosen N numbers from 0 to N from Rm, hence N is obviously less than M, and we have also said that N is equal to M. Therefore we can say here N is less than equal to M. And this is our third statement. As you can see here, this is our third statement, hence our third statement is also true. So as you can see, in option 2 we have only 2 is true, but in option 3 D we have only 2 and 3 are true. And since statement 3 is a true statement, hence our answer will be option number D. So I will like to end this video here. You will find solutions to the further questions in our next videos.